Hi, my name is Robin Seibold, and a while back I participated in Portland Indie PIGSquad's game jam titled Finish Your Game. A game jam is an event where the participants develop a game according to a set of rules. This usually includes a time limit and a theme. This jam, however, is a little different. There's still a time limit, as well as a theme for the participants that want a more traditional game jam experience. But the main purpose of the game jam, which reflects the name of the jam better, is to work on a game project of the participants' choosing and share the progress made during the time frame of the jam. The jam ran from November 11th, 2020 to November 23rd, 2020, UTC+1. Considering the time limit, I chose to work with tools I'm comfortable with, and those are Unity, which is my go-to game engine, Blender for the 3D assets, and GIMP for the 2D ones. And given the rules of the game jam, this seemed like a perfect opportunity to develop one of the many game concepts I've scribbled down and stored in a folder, but never seemed to have the time to conceptualize. I settled on a small puzzle game, including a visual art style, both of which I've wanted to experiment with for quite some time. The game I decided to make is a simple grid-based puzzle game, with no sort of timing-based or stressful gameplay. The grid will be a 3-dimensional grid, but I will simplify it as 2D in this video for visibility. The player will control X number of characters, but only one at a time, and will be available to swap between these at any time without the swap counting as a turn. A turn will execute every time the player moves one of the characters. This will also increment the state of everything else within the grid. One could say that time stands still and increment one step every time a controllable character makes a move. The grid, or game board, will be partly populated by static objects, making some of the grid unavailable for the characters, as well as different kind of movable objects. One such type of object will be pushable and can be moved around by the characters. Another type of movable object will be the enemy object, which will have a predefined movement pattern, including the possibility to just idle, i.e. stand still. If a controllable character and an enemy occupies the same grid square anytime during a turn increment, the player loses. This sort of gameplay, and depending on level design, opens up for the player to fail a lot. This means that except for the movement and swapping between character controls, another good thing to have is the possibility for the player to revert their moves, including reverting back multiple times in a row, right back to the initial level state. To complete a level, the player will have to move all the characters to separate goal-marked squares, without getting caught by the enemy. To make it a little bit more strategic, each level will have a maximum amount of moves available. Converting this game description to a structured and modular format left me with a game board class, which unsurprisingly will hold the data representation of the game board in the form of a 3D matrix. As for the occupants of the game board, they are represented by a class named GamePiece. This class is virtual as to allow for another subclass, Moving GamePiece, to extend it. The base class GamePiece is used for all objects on the game board that are static, while Moving GamePiece is used for movable objects on the game board, that is, characters, enemies, and pushable objects. Overseeing this is a game controller, with references to the game board, as well as some user interface classes and a camera controller class. Lastly, I converted this into a list of manageable tasks, and then I could finally start writing some code. The implementation went pretty smooth, and I won't go into too much detail of it, but instead I will talk about a couple of key points. I began with the component with the least dependencies, the GamePiece class, which I implemented like this, where GamePiece type is an enum that defines the type of GamePiece, and turn state is a struct that stores transform relative data for a turn, in this case for the initial turn. Apart from direction, the variables are self-explanatory. Direction is a variable of type direction that represents which direction the GamePiece moved to end up with this state, and is in the current build only used for the push mechanics. After GamePiece, I implemented the derived class Moving GamePiece, which is a bit more complex. The first thing I want to mention is the direction array called moves, which defines a movement pattern, independent from the player input, for that specific GamePiece. The enemy movement will be specified using this array. Secondly, we have a stack, which will store all the previous states for this GamePiece. I found it easier to implement mechanics like push if each GamePiece stores its own previous states. There's also a variable for next state, and this is because I chose to split the movement of a game piece into two parts. In the first part, each moving game piece on the board updates the next state variable, and this describes where the game piece wants to move, but is not final in any way. In the second part, the next state for each moving game piece gets validated to see if such a move is even possible, and then the game piece moves accordingly. Let's take a look at the methods related to part 1 for creating a new move. One takes a direction parameter, while the other one fetches one from the moves array. These two methods just define the next move the game piece would like to take. If the validation fails, for instance if the move is blocked by a static object, the reset next move method will be invoked, which basically just changes the position of the next state to be equal to the current position. The update state method is called in the second part after validation, when the next state should be finalized. This method adds the next state to the previous states and also starts the game piece movement animation. The last method I want to show in moving game piece is the revert latest move method, which reverts the latest move by removing the topmost state in previous states and sets the transform of an object to be equal to the state next in the stack. Next, I implemented the gameboard class. The gameboard class will also work as a level, so when I later create the level prefabs, the gameboard component will be attached to the topmost game object of that prefab. Since each gameboard is its own level, the gameboard component has the number of max turns variable, as well as a completion flag. The gameboard grid will be represented by the game piece matrix called grid, and gameboard also keeps track of every moving game piece on it. In the start method, every child game piece is found and added to the grid matrix. Moving game pieces are subsequently added to the moving game pieces list. This list is also ordered based on game piece priority. This priority decides in which order the turn state is updated. In the current implementation, the order is not that important except for the fact that player game pieces has the highest precedence. The move game pieces method is called when a player input has been registered and a turn should play out. Here, the two parts I mentioned earlier are visible. In the first for loop, the next state for all game pieces are calculated, and in the second one they are validated and the move state is updated. Which brings us to the most important method in this class, if not in the whole game, the is state updated for game piece possible. Since the goal was to make it seem like each game piece play out its turn simultaneously, the order for checks was of high importance. First, a few simple checks are made, like is the new position within the grid? Is there currently any game piece at that position? If so, is that game piece a moving game piece? If all of these are true, a couple of more complex checks needs to be done. If the other moving game piece is moving, the only thing we care about is if it's moving in the direction of the game piece for which we are checking. If it's not, the game piece can move and the method returns true. Otherwise, we check if a push event is possible. If so, we recursively push the other moving game piece. If possible, of course. Lastly, if a push event was not possible, we check for a catch event. Should one of the moving game pieces catch the other one? If a catch can happen, the move is possible and the method returns true. Otherwise, it returns false. As can be seen, there's a lot of other methods in this class. I won't bore you with the details, but as you can see, there's methods for checking if the win or lose conditions are met, and both of these are called from the game controller class. The game controller handles quite a lot, maybe a little too much, and ties everything together. There's lots of references to both user interface components as well as the camera. The game controller also holds the gameboard prefab array, which is essentially all the levels of the game. Most of the logic happens in the update method, where input from the player is recorded and handled. I won't show the implementation since it's basically just a big switch case that calls other functions based on input and a couple of booleans. What I will show, however, is the execute move method. This one is called if the right input was allowed and triggered. The input is basically passed on to the current game board, the move counter is incremented, and then the different conditions are checked. The order of the current implementation allows for players to use their last move to reach goal, and it will count as a level completion. Both characters standing on a goal marker each, where one or all markers are also occupied by an enemy, will count as a loss. There is a lot of other stuff going on in both classes I've shown and classes I've not. Like I said previously, I wouldn't cover the implementation in detail, so this will have to conclude the implementation part. So at this point the game logic was pretty much fully implemented, but the game still looked like this. I'm a big fan of simple geometric art, but this is not it. I had a clear idea of the visual design I wanted to try out for this game. It's somewhat of a playful realism, and is apparent in a lot of games these days. One example is Sackboy: A Big Adventure. Another one is Yoshi's Crafted World, which I personally think does it exceptionally well. And of course the Paper Mario series. I have even worked with this style in a previous game of mine called Doki Do, and I've always wanted to revisit that style. Besides the visual style, I also envisioned that the game would take place on a game board and resemble a real-life board game. So with both the setting and visual style planned out, I started to model the static objects. More specifically, I started to model the table that the game board will be positioned on. I wanted to keep the model simple and let realistic textures do the heavy lifting. I then placed the table in the scene and surrounded it with some planes, which I textured with a wallpaper texture. This, together with a plane underneath, with a marble texture, made it appear as a beautiful room, perfect as a backdrop to the actual game content. Next, I modeled the game board. I chose to have a baseline in felt and some edges with a nice wooden material. Continuing the wood theme, I modeled the game board pieces as simple rectangular squares with rounded corners, which will lie on top of the felt base. They were not that hard to model, but since I wanted to avoid a repetitive look, I needed to create a custom material that displaced, rotated and scaled the game pieces based on a position, with the help of Perlin noise. With the base in place, I could start to model the actual game board content, and I started to model some stones which will work as movable game pieces. And to diversify the levels a bit, I also modeled some props, which doesn't impact the gameplay, but just adds to the visuals. All of these I modeled as paper cutouts. I also did the goal markers on the same theme. With all static game assets done, the scene looked like this. I was really happy with the result at this point, but the scene looks kind of dead. So to liven up the scene, I created a simple dust particle effect. I also added a depth of field post-processing effect, which I'm a big fan of. Next, I started to model the actual characters. At this point, there was not that much time left of the jam, so to save some time, I chose to have the same model represent both the player-controlled characters and the enemy characters, but with some minor changes. A couple of spheres would act as eyes. I also added a couple of horns to the enemies to make them extra fearsome. I envisioned the characters to have a crocheted design to really tie together the handmade visuals of the game, and I kept the geometry of the characters simple. After rigging, I created a few animations for walking, sleeping, idling and fearsome idling. Next up was the user interface. Something that goes extremely well together with the visual style so far is skeuomorphism. So the main menu was modeled to look like an open book, while the in-game information like controls and the move counter will be represented as a ripped page from that book. Both would be displayed in the actual game world and not on a canvas layer. The implementation and visuals were now pretty much done, but I still had no levels. I decided that I would design the introductionary levels and outsource the design of additional levels to my girlfriend. As for the intro levels, I wanted to convey the game elements to the player, without explicitly telling them. For the first level I introduced the movement, changing of characters, the fact that both characters need to reach separate goals, and that there's a move limit. The first three are explained by the control description note that will be to the right of the game board, the visuals of the goal markers and the fact that two characters can't stand on the same spot at the same time. The move limit is also explicitly visualized on the cheat note, but to really underline it I tried to place the characters in such a way that the player wants to move the first character directly to the goal 2 moves away, and while moving the second character the player would run out of moves. The second level would introduce the push mechanic to the player. This was achieved by locking one of the characters in, and the only way to beat the level within the move limit is to use both characters to open a passage. The third level expands on the push mechanic, and here the fact that you can push other characters as well as multiple objects at the same time is introduced to the player by the initial positioning and a move constraint. There's no way to get both characters to the goals without actually pushing one of them. These 3 levels, together with the 4 ones outsourced, would unfortunately be the only levels in the game at release, because at this point, the jam time ran out. At the start of the jam, this game was nothing more than loosely written down ideas, and over the course of roughly a week, a game emerged. I'm personally very happy with the result, both how it plays and how it looks. There's however a lot of ideas that I didn't have the time to implement or design, as well as some that got cut. The most crucial thing, however, is that the game currently has no audio or sound whatsoever. This is what I'm most disappointed with. The time limit, together with the fact that sound design is the part of game development I'm objectively the worst at, are both factors that led to this. Sound is a crucial part of a game, and there really is no viable excuse for the lack of it. The game in its current state does not really utilize the 3D grid. I had some ideas of levels that would take place on different heights, but I eventually did have to scrap them because of time issues. Similarly, there are no actual visible static game pieces in the game, only invisible ones, as can be seen in level 2. Instead, all the stones are pushable in theory, but their position might make them unpushable. The game is also extremely unoptimized, with bloated textures and pretty much no instancing at all. But since this is a game developed during a game jam, I think that's okay. I could go on about missing features or bad implementations, but overall I'm extremely happy with the game, and I would really like to end this video on a good note. So thanks to Portland PIGSquad for a beautiful jam, and thank you for watching, and have a great day.